So you can find all of the tutorials on GitHub for this Lua lesson. The GitHub username is Elation Foundation, and the name of the repo is called Learning Lua. I took the beginnings, actually like about half of this, from a guy named David Shiro. David O. Shiro is where I forked it from. You can see that if you'd like to check out where it began. He did a lot of this work, and I have a lot of praise for that guy. You can feel free to fork, and I would love if people forked and played with and added code to this or added new examples. Preston, do you have Lua on your machine? Were you here for that?
I believe I have. I did that over a year ago, maybe.
Perfect. I'll put a little thing whenever we post this video with links to where you can get Lua for those who don't have it. You should really get in the terminal and follow along as we're going to test out, kind of these statements, because it'll be a lot easier. Also on github.com/elationfoundation/learning-lua. Learning and Lua are both in caps. I've formatted all of the tutorials to go along, so you can use the formatted document. It's a lot prettier than the text files that are listed. So we're going to start with data types in Lua. We're going to move somewhat quickly, but feel free to stop me. I just think because we did a lot of these data types before, we'll be able to kind of quickly jump through them. Apologize for my occasional silence, those in the videotape. I have coffee in front of me, and I plan to keep drinking it. So Lua, like the main useful, in my opinion, data type, and we'll see more on this when we get to arrays, is the nil value. So this is an undeclared or empty variable, has this value. This means that if you ever call for anything that doesn't exist, you will get back nil. It'll return to you there's nothing there. That variable doesn't exist. That place in the array isn't there. So it is pretty much the default. So as you can see, I have a couple chunks of code here. One is just print x, when x hasn't been defined yet ever, since this is our first line of code. We'll return nil. If we then define a y, we say, hey, local, by the way, says I want y locally here. You can define y generally, but you can also define it locally, and that's valuable for Lua. And we'll talk a little bit more about why local scoping, as we call it, is so valuable. Just like with functions, you can have scope within that function. If you define local y but don't put it equals to anything, local y is nil, even though you've defined y as a variable. Now, nil is essentially, with our Boolean values, false will return nil. Now, false is its own value, but false is considered nil as well. So that's how you can do if not false, and it will return, yes, false is not there. Is because false essentially equates to nil. So nil is the same as false, though nil also includes, it is also used more widely when it's returned as other things. It's how Lua returns a nothing value. It won't return a false, it'll return a nil. And so, as I said before, true and false, actually I didn't say it before because this video is different. In the Booleans for Lua, true and false act as traditional Boolean values, and nil is the ultimate false. Unlike other programming languages, all Lua numbers are floating point numbers. So you don't have to worry about changing a number in Lua to the correct float or integer and multiplying numbers together that have digits behind them and the like. They're all the same type of number. You're going to find in Lua they did a lot of work on getting everything to be common across so that you can manipulate objects very easily as long as you translate it to the kind of generic type. So strings can be enclosed in double quotes, single quotes, or brackets in Lua. This is useful because you can put single quotes inside a double quote without it breaking the string itself. And you can use brackets in order to make a multi-line string. So if you want a string that's, let's say, a paragraph that's formatted with spacing to be a poem, and you want to pass that poem, you can use these brackets here to specify a multi-line string. And actually,
There's no closing brackets.
I didn't put closing brackets on this. This should, have multiple lines and then closing brackets at the end, but you can have double quotes and single quotes inside of brackets. So they can also be useful for single line strings where you want to have things like send this quote with the quote marks. It's important that we output the quote marks. Brackets can also be used, to do very long, intense strings with large, what are they called? Indentations and formatting changes. So let us keep going down. So strings allow for escape sequences to be put in. So things along the lines of a forward slash, is that correct? The slash that goes from top to bottom. This forward slash here, 4 quotes, will allow you to have double quotes within a double quoted string, because what you're doing is saying this quote that's coming up isn't used as a control. In fact, it's just a string value. And so these escape sequences,
I think that's a backslash.
okay, so the backslash allows you to say, don't read this next thing as part of the program. It doesn't do anything for Lua. It's part of the string. Don't worry about it. For things like a double bracket, or something that looks like a variable name, or a quote. And so that can be very useful. And you can also use it to instantiate control characters like newline, which is a \n, or tab, which is a \t. And these are traditional characters you can find in regular expressions, as well across pretty much all POSIX systems. And so you can use those within Lua strings, and they will be formatted correctly. You have to, if you want an actual backslash in some text, you have to go \\. And what that will do is it'll escape out the escape character, so it'll just be read as a regular character. So 2 backslashes will become just a single backslash in a piece of text. Now, the way that we combine strings together is with 2 periods, and this is how we do our concatenation. So if we have x equals hello and y equals world x, I'm going to call that like a half ellipse y, x dot dot y will make them hello world. And this allows you to put variables into strings that will be then translated out into the full string. So for instance, if you had the x equals the ghost said boo, dot, and then you went x dot dot space is the quote of the day, then it would concatenate, it would take x and extract it out and then concatenate it with the other string. This can be dangerous though if what you're trying to concatenate isn't actually a string. For instance, it's an array that has a string in it, and so that's something to be careful for, but not currently necessarily relevant. And then also the hash mark, what is this called? The thing, the number thing. Is it hash? Pound, yeah. Bash or pound. The pound sign is used to give you the length of a string. Now the cool thing about this is, which should be noted, strings are essentially tables of characters. Now they're not shown that way explicitly, but they are just a string of characters that the first letter of the string is number 1, then number 2, then number 3, so that you can actually like look into a string. And let me get my terminal out so I can show you guys what I'm talking about. And I think I can do this. I can't. I forget how to do it. There's subtext that makes this a lot easier to do. But anyways, the idea is that the pound sign can be used for strings like this and also for arrays to count how many items are in an array. It's a lot more dangerous with tables, which are the arrays that we use in Lua. And we'll talk about it a little bit more. But just know the pound sign for objects that you know are pretty consistent and don't have nil values strewn throughout. Again, that nil is a dangerous and powerful thing in Lua. You can use that pound sign to identify how big it is, how much is in there. For strings, it's how many letters. For arrays, it's how many items. And that brings us to tables. So Lua calls its structure for collected things a table. Tables are associative arrays. So the indexes for these arrays are automatically given if you don't assign them yourself, but you can assign indexes for items in the array. So in this example, where we have the string A, B, and C in these curly braces for the array, so x equals this array with curly braces, and tables are always using curly braces like this, and then these three strings separated by commas. The kind of underlying context here is that in this array, the first item is A, the second is B, and the third is C. And unlike pretty much every other language in the world, Lua indexes its arrays starting with the number 1. So when you want the first item in an array, you ask for the 1 item in an array. When you want the second, the second, the third, the third. This actually makes it pretty easy to call the last item as -1 and the second to last item as -2. So if I want the second to last item in the array, I can go array give me -2 item. Or if I want the second item, I'm going to go array give me the second item. Where in languages like Python, you have the 0th item forward. But then if you want the last item, it's -1 and -2 and -3, and it breaks the indexing format. Lua doesn't do that because it indexes at 1. Also, it's annoying because it indexes at 1. But so what you would do to get the first item is use the inherent index, the name that it was given that you didn't specify, which is 1, to get that first item. If, for instance, though, you wanted to give each item a name, you could. You could say the name equals John, and age equals 21, and Ismail equals true, and that means that the name index is John. So you could actually print, instead of x1, you would print x, or in this case y, dot name, and I don't, oh, here we go, or y dot name in the same format. You can use brackets or that period. And we'll talk a little bit farther down in more depth about this, but essentially a period adds inherent quotes to an item. A bracket, you have to put the quotes in yourself so that you can put something like a variable that translates out into a string in there, or even a function that returns a string. So give me the item in here that this function defines with the brackets, whereas the period is just the string in that array. Also, please feel free to stop me, ask me any questions, or ask for clarification at any point throughout this, because I know I'm breezing through this pretty quickly. And there's a whole array section where we'll go in more depth and everything. So I think I just covered that, so we're good. And again, and it says it here, the length of a table can use the hash prefix to identify the length of the table. It's not always true. It should be taken, if you know the table and you know it will never contain any null values, this can work. And we'll actually give some examples later of how it breaks and how to do that correctly, using the for loops that we're going to go over. And then if you're unsure of what you're dealing with, there is a function that's built into Lua called type. And you write type, and then you pass type whatever you want to know what it is. Oh, sorry. Whatever you want to know what it is, and it will return the type of the value. It will return the type, and let me check real quick. So I've been programming a lot. Yeah, it returns the type as a string. So then you can compare the string that is Boolean, for instance, or number, or nil, or string, or table, against, in quotes, a string that says that. It's not a unique object on its own. In some languages, like the type function will return like a special variable, much like a Boolean variable, or like a true, or a false, or something along those lines. That is a special kind of like thing that can be called as a variable. This isn't a variable that defines number. It's a string that says number, which makes it unlike Python, for instance.
Did you also query inside of a table or index?
Yes.
Okay.
In what way?
Like you wanted to query the type inside bob.builder.
Yeah, you'd go type bob.builder.
Actually, builder.type.
or builder.bob if we're using some sort of better object structure. So that is Lua data types. We're moving on to some deep dive into strings. So here's what we're going to cover and more, because I forgot to update this index from his original guidelines. So here are some actually correctly done multi-line strings. Double brackets, as many lines of text as you want, double brackets. It will respect the breaks in the line, as well as special characters put in here, like new lines, so that you can do things like I want tabs at the beginning, but I don't want to actually space out my tabs in my text. As I said, again, escape characters do work. Concatenation uses the double period. And then we have the string library. And this is actually where strings become useful and interesting. So the string library is a set of functions that are actually built into strings themselves, so that you can use these functions from a string as if it's an object. Now this becomes pretty cool, because you can do things like x equals hello world, and then x, and then right here, notice we're using a colon. If you can see that, should I make the screen bigger? Can you all see, by the way? Okay, so when you're going into an array, you use a period. And that identifies an object within that array. If you have a structure that has functions in it, an object in this case, which strings are an object of this type, and they use metatables for this in Lua, which we'll cover at the end of this section. You use a colon here to specify essentially like my version of find, because you can specify a special version of find for yourself, for this object. Right? I want the find function to do this. So if you have a function called find up here that does cool things, you can just call, okay, now run the find that's within x, the string find. You could also just use, and let me find a use of it in the old format, this format here, which is, use the string module and use its format function on me as I am a string. But because strings contain the string module, they get to use the colon to say, I have the string module, so I want to use my specific version in case the string module one's messed up or doesn't exist. As a string, I inherently have it, so I'm going to use the colon to use find for or within hello world.
So find is something included in the library or something you wrote?
No, find is included. Find is actually, it's not even just included, it's part of a string. It's in the
Every
string's
string has
metatable.
that function
Yeah.
built in.
So it's just like numbers have the add function built in. So when you use a number with a plus and another number, they know how to interact across each other. And it's not a direct correlation, but strings have a find thing. And so they include this function find, and in hello world, find returns 8 and 9. Most of the string functions return the indexes to the string, like where you can find this thing. So if you go, now give me between the 8th and 9th letters here, so 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the or right here. You can pull that out, and that's what I was talking about, how strings are like arrays, in that you can use these indexes to pull out and then call parts of strings, as opposed to it returning the or to you, so that you can manipulate the original string instead of having to create a copy of the string or a new string to manipulate it. Lua is a very small language. Lua fits very comfortably on a floppy disk. And so Lua's string functions and string library is built to replace what would normally be a regular expressions library, a very powerful library for manipulating language and identifying and parsing language, which when it was implemented was larger than the entirety of Lua with all its libraries itself. So they didn't implement regular expressions. Instead, they implemented these string functions. One of the things string functions do is they use this kind of minimal approach of giving you the indexes to call for most of the functions. There are functions that don't do this, and we're actually going to come down to one that doesn't do this. Also, if you use a string function and it doesn't find what it wants, it will return nil. Much like any function that doesn't return anything to you will return nil. You'll get nil if you call that function and assign it to a variable because nothing came out.
So it's still unclear. Is there a functional difference between nil and null? Or is it just
There's no null.
It's just
Null is a thing that's not claimed. You can use it. But I wouldn't use it, but you can use it. It's
right,
not
but nil is just Lua's null. It's a semantic difference, or
Are you talking about C?
yeah.
I'm not fully familiar with all the
Okay.
complexities of null, but I assume probably.
It looks like it's used pretty much the same.
Yeah.
Do you know?
I suspect that nil in Lua may have additional properties, right? I mean, null in C is literally a null memory value, like a null byte.
It points to the null
Yeah.
byte.
So,
Yeah, if that's all it is, then no, nil is used by Lua in a lot of ways.
yeah.
Okay.
It's passed and then manipulated and thought about in the programming language. Like, it's part of the design.
Okay.
So we'll get, when we start talking about nil and arrays, we'll get into a little bit more depth about. I think it is probably just a null byte, but it's explicitly a null byte. I mean, like, and this is one of the reasons why it's really hard. Anyways, yeah, we'll talk about it.
I suspect that you use it in most of the same ways that you do in C, and then plus a bunch of other ways.
So that was find, and find just returns the beginning of the place you're looking and the end. This other one, which is actually my favorite of all of the string functions, is gsub. And we're going to go deep into gsub when we start talking about like passing anonymous functions to other functions, and like how gsub is friggin' awesome and does even more than I'm going to describe later. But gsub essentially, and in this case, you've taken hello world and made it x, and then you've used this string's gsub function, again we're using that colon, to find world and replace it with David. And so we end up with hello David. Because hello world finds world, places with David, and then gives you a new string, hello David. And if you do, for instance, gsub hello world 0 and period, you'll get HELL period, W period, RLD. So gsub is really useful for, I mean, this is cool, it gets way cooler. Remember gsub, it's the bomb.com. So this is string format, which starts to get into some of the more, like some of the actual like string pattern recognition that we're going to talk about in the next module, which is just in a couple minutes in a lot more depth. But what it's doing is it has a value of apples, which is a string, and it has a number, 0.5 for y. It's using the long form string dot format function, because if you're calling any array, and almost all modules are kept in arrays. In fact, all of Lua's functions are kept in a giant array called globals. Actually, it's called _G is how you call it. And this might be a good spot to talk a little bit about that. If I derail too much, stop me and we'll come back. I apologize for going ahead of our. We haven't gotten yet to arrays and really delving into them. We did in the beginner session this morning, or the intro session. But this is every function that my Lua knows about right now. What I've done here is I've iterated through all of the globals, right? This _G, which is literally an array of all the functions I'm going to use. And so when we're dealing with string.format, which is right here, what we're actually doing is saying, and there's an implicit _G dot, and then where's our string? Dot string,
See, it's an array.
and so there's _G, and then we'll look in the string array. See, it's a table, and there's where the table lives. That's its memory location. And we go G dot string, and then from here down are all the different string functions we can use. And these are just straight up functions sitting in this array, indexed by name, byte, dump, gmatch. There's gsub right there. And I think, what are we using right now? We're using transform? Format, we're using format. And so there's format. So when we say string.format, what we're actually saying is, in our globals, because we haven't defined another array to look in, and we can set a local array. We can actually say, here are the functions I want to deal with, and I'll put them in an array and use them the same way we do here, which is string.format, globals.string.format, and that is a function. So then we use our parens to actually define, now we're going to run this function. And format essentially takes a string, and then it has two variables here, One is %s, which is, I think, string. I want to get, see, I'm going to open my patterns real quick. I'm going to open them.
String, and the other one's a float.
Is that a float?
Yeah.
Yeah.
It's like the exact same syntax as C, almost identical
Yeah.
to C, except you don't need, it's just a printf command.
The cost, yeah, string and float. Yeah. So it's essentially printf. So string and then a float per pound. And since we have 2 items here, you pass it 2 variables. The variables are apples, cost, next variable, y, 0.50, because it's a float of 0.5 per pound. And so you get the same functionality you'd get from printf with string.format.
I don't want to get into anything too complicated, but just like a quick question. Can you use that to like overload functions? Like write your own version of a string function and then change the table?
Yeah.
That's awesome.
Yeah, you can, and so we'll talk a little bit more about that when we talk about metatables. There are, you have to do it with an array. You have to do it in a table. It's the only place you're allowed to mess with the metatables of. So there's some really powerful things you can do with that. And we'll talk a little, maybe there's a whole module on it a little bit later. But that's where Lua starts becoming really cool. Is that you can create, for instance, a table that holds only one string that has a whole series of functions that you can play with that you've built around strings, and then you assign that to, I mean, essentially you blow away string and you assign it to the string. And so therefore your strings are essentially an array, but when you use the print function on them, they pass back. So when print's called on them, they pass back a string that's formatted correctly. It's really cool. This is when I stopped hating Lua and started loving it, was at that
Even
point.
crazier question, is there an operator table and can you overload it?
Operator table?
Like one of the things I miss the most from
Oh.
C++.
Only with
Next time
metatables.
Okay.
So only with arrays.
So I can do that, like I can say that the equal sign means something different for this type of object.
For that object, yeah. So we can do, let me do it right here real quick. So if A, and here's our original array, and then A add equals, and then you'd go and you'd write your function for how you pull from one table and pull from the other table and manipulate them together. It's really useful for matrix algebra, and it's actually the implementation I saw that really got me excited was a matrix algebra version where they essentially said like, oh, well, if you want to add 2 arrays together, that's our union. So there we go. That's how unions work. This is how you subtract them, and that's a difference. And so a very simple version of that. But yeah, no, metatables are incredibly powerful and can manipulate. I mean, all the operators have a special name, like __add, or maybe it's just one underscore. Anyways, Lua uses underscores like a lot of higher level languages to say like this is a saved space.
Yeah.
But with metatables, you don't have to respect that at all, especially because we don't have a table plus table. The operator doesn't exist for tables, and since you're defining it in the tables scope, it'll operate as such. And but we can go deeper. I don't want to until we get there.
I didn't want to get down a rabbit hole. It's just the first thing I thought when I saw the globals table, and I was hoping to get the answer that you gave me.
Yeah.
It's really quick. So a table and array are synonymous? Okay.
Yeah, sorry. I should be saying associative array. All of Lua's arrays are associative arrays.
Okay.
They just have automatically assigned numbers to them if they're not being used, which is cool also because, and we'll talk more about this, but you can actually have a numbered array that's just a normal array and then assign one of the keys to something else.
To one. Could you assign a key to one element, not the other one? So.
I mean, you can do all sorts of crazy stuff. Most of the time you don't want to. I mean, it's definitely one of those things where you can shoot yourself in the foot and you'll blow your whole leg off. Like it's like the worst of both worlds. It's also really cool.
And they're called a bunch of different things in other languages too, like maps or dictionaries or
Yeah.
different things.
Yeah. But tables is how Lua calls them. Strings have a bunch of cool functions. Lowercase, which is lower. Upper, which is upper. Reverse, which just reverses the string, which I just think is like how often do you need that, but it's cool. And then length, which is the length.
Sorry.
You're
We're
right.
always pound drums.
Oh, nice.
Yeah.
You could make a really easy dictionary palindrome checker with reverse, actually, yeah.
Yeah.
So there's also a length function, len, which shorthand is, again, the pound and then the string, which actually just calls, I believe, the metatable just calls the length function. I could be wrong there, though. So that's strings. Let's talk a little bit about patterns. So because Lua doesn't use regular expressions, Lua uses this pattern library, which has similar amounts of functionality if learned and used correctly. It will never be as powerful as regular expressions, and it will make you sad sometimes if you're writing in Lua. So the escape character for patterns is not the normal escape character. It's actually the
I said, why would it be?
Yeah, well, because strings allow full escaping in them already. And so when you add that in, then it basically it limits your ability to have your regular expressions different from your escape characters. And they want to use things like, they don't have a T or an N. Damn it, I was hoping that there was an easy explanation. Either way, they use percentage sign. Like regular expressions, a period represents all characters. Again, if you have a period and you want it to just be a period, you can put a percentage sign in front of it for pattern matching, and it will make it in just a normal period. A represents all letters. C represents all control characters that are in your string. So that \n, it will match both those characters as one control character when you're playing with strings. D is all digits. L is lowercase, P is punctuation, S is spaces, U is uppercase, W is alphanumeric characters, X is hex digits, and Z's fun. So Lua used to not be able to handle the special character of \0, like the 0 character, the null. Is it null? What is it?
Yeah, \0 is no.
Yeah, so it couldn't handle null, probably because it was dealing with the nil issue. And so they implemented Z to find null. Because if you tried to look for \0, everything would go wrong. So depending, now if you have the second, it's 2.42, I believe, you're good. You don't need Z, you can just look for null as a special character and it'll find it and all that jazz. Before that, you need Z. So I use Z if I want to find null characters. Null characters are great because they're used by a lot of things, especially binary code, to exit out, and a lot of programs say this is the end. So it's there. It's annoying. Remember that if you ever encounter a crazy error because you got an escape 0, a null value, that's what Z is there for. And so here are also, shouldn't be in a separate box, but I wanted to separate this out just for when people read this when I'm not here. X here represents, it's a variable. It's not the character X, where all these are characters. Any letter or any character that's not one of the special magic characters just represents itself. So if you put an A as your pattern and the thing is AAA, it'll return all three of those A's because it matched as A. And then %x, where it's any non-alphanumeric character like this, represents the character X. So those special characters, these guys, you put a % sign in front of them, and it makes them normal again. It makes them that character. So if you're looking for $signs, which usually represents the end of a string, you just put a percentage sign in front of it, and it'll match the $sign itself. It escapes it out, much like the / does with the rest.
Can you do that with \, or you have to do the / /?
You have to, so with this, you don't have to worry about the / in the pattern because / doesn't have a representation in this. But personally, if I have a pattern and I'm matching any non-alphanumeric character, I throw a percentage sign in front of it because it doesn't break anything. It allows you to do that. But just in case something weird goes wrong or I have missed a character here, you can always, on a non-alphanumeric character, put a % sign in front of it and be fine with it, including a % sign, which you have to escape with a % sign, just like the \. And then finally, brackets. With anything in them, it's a set. So if you have ABC in brackets, you're not matching for the string ABC, you're matching for any of those letters as one character. So the brackets actually allow you to, and this is much like regular expressions, so as you know regular expressions, say anything in this bracketed space is going to be what I'm looking for in this character. And then you can manipulate that bracket as if it is a single character using some of our modifiers. So I have some examples here of like if you want to match any character, you can use a period using our string.match function. And then here's our hash again. Match, you usually pass most of the string matching functions. You give it the string first, then you give it the pattern, and then anything special afterwards. Unless, of course, you use the colon, in which case it operates on itself. And so there's a hashback. Here we're using some special characters. So we're just looking for the special characters, and we get, star, because we have anything, special character, anything. And continuing, please feel free to explore the usage of those, because now we're going to go to fun pattern stuff. And we'll do more fun patterns afterwards. Wait, go ahead.
Just so, could you show us an example, maybe, or describe an example of searching the hexadecimal characters for an X?
Searching the hexadecimal characters
Yeah,
for
because the search the hexadecimal digits is %X, and then I'm confused of whether you'd search for X or %X.
You search for X.
So you'd search X and then put
If you're looking
%X.
for an X in a hexadecimal string,
so X.
because X
comma
isn't a
%.
hexadecimal string, right?
It's not. It's true.
So like if I have a hex string, and let's do this. Let's do this. If I have a hex string, gosh. So if I have a hex string such as A123F, it's nice usually if you actually assign that to something. So if hex equals A123F, and I want to do, we'll do.
Is it case sensitive at all? The hex notation, because I'm used to seeing either lowercase or uppercase. Is it going to freak out at all, or?
Let's see. We'll do. We'll just screw it. We'll just do. We'll look for if there are hex letters here. Now notice, I used hex colon match, and I just gave it the pattern. If I wanted to do, and here we'll see. Oh, I should actually print this out so we can see it, right? You can also, in the terminal, you can use equals to return it. And it actually auto-completes to return this value instead of putting a print statement around it. Only really works, obviously, in the terminal, where any returned value it's printed out to the screen. But so we find that, the hex works for a lowercase and uppercase in this version. But now if we just wanted to actually find the letter X, because it doesn't actually exist in that string, and X isn't a legitimate hex value anyways. Now if we were looking, no, I was going to say I could escape out the X, but no. Yeah, that is our...
Okay, yeah.
And so a single match only returns the first instance that it finds.
The match function only returns the first match. Now, if we did something like this, so any hex value, and then we want, and this is where we're at right now, which is the how you use patterns. We want any number of those, and let's make it even more specific. Remember how we had that $? So let's say we want any match that goes to that $, which means end. So the match this specific function returns the first instance it finds that matches this pattern. And the first instance it finds that matches this pattern should be everything. And there's some caveats to that, which we'll get to in a second. Or not caveats, there's just some like useful things about especially the plus sign, which is, we use right here the plus sign, which is one or more repetitions of an object. The asterisk multiply sign matches 0 or more, so you can actually have something where you say like, if this is there, match it. The minus, which is my favorite, matches 0 or more repetitions, just like the star, except for it matches the smallest amount it can. And the reason for this is that the star, the asterisk, is greedy. So if you give it a pattern, and actually I have it down here, so I'll just go really quick down to that pattern. Here we go. If you have a pattern, like first name, last name, right? And so what you're looking for is anything that I want, like any amount of characters, and then a space, so I capture first name, because it only goes through first name. But the person who gives me that string accidentally puts a space on the end of last name. What it'll end up receiving is first name, last name. Because it's greedy, it'll go all the way to the end of the string and find the biggest match it can find. Whereas the minus sign, period minus, finds the first instance of it and then stops. And so the star is really useful when you want to get as much as you possibly can. Minus is very valuable in string matching because it is essentially, if you were doing regular expressions, it would be the star with a question mark after it. It just makes it very stingy in what it returns. It returns the smallest amount it possibly can. And so I find the minus is an incredibly useful thing. Yeah. And then there's the question mark, which returns 0 or 1 of the results. So if you have a letter that you don't, like, for instance, apostrophe S, and you want to just say, it might be plural, it might not, you can put a question mark after apostrophe S to see if it returns or not. Well, actually, you'd have to do more than that because it's 2 characters and you have to put them together. But still, yeah. And then the percent and then a number. This is not actually n here, I want to point out. Some of the string matching functions, and we're going to do some examples in a second, they look for the different times it matched it. So if I say find me the letter A and it finds 20 A's in my string, I can reference them. Actually, it finds 9 in my string. I can reference the first 9 of them using percent and then the number. So the second A, do this with. The third A, do this with. Really good for substitution, where you can actually say, okay, so find me all the words in this, I'm going to get a name. For the first word, I want you to capitalize it. For the second word, I want you to all caps it. Or I want to switch the 2 words. Like I want to receive a name, but I'm always getting first and last. So if I get first and last, switch them to last and first. Number 2 switches with number 1. And we're going to go deeper into how this works, but while we're here. And then the really cool one, which I love, which I never get to use because it's kind of weird, is %B. And then this X and Y are 2 unique characters in the string that you want to identify. So for instance, if you have a piece of HTML that has like the little triangle-y parens around something, and you go %B, open paren, close paren, it'll actually identify and capture those parens and anything inside of them. So it makes it really cool for things like translating one language into another, or translating really like code, for instance. If you're doing things like string parsing, not string parsing, running strings. Lua has a series of functions to actually take strings in and run them as Lua code. This can be really helpful for actually identifying what are the variables I'm getting in the beginning, or for instance, identify function and then end. And so it grabs the last end of the function and anything in between it, so it can actually parse out chunks of functions. You shouldn't, by the way, run random code in your Lua programs, especially not if you're working on the routers. Bad, but you can do it. Patterns can contain subpatterns enclosed in parentheses, and that's how you would do that parenthesis S, and then, for instance, parenthesis S and then question mark for plurals, is that you can use the parentheses in order to capture those those smaller components. The problem is that they also return those captured components, and so by using the %n, you can identify which one you want to return back, or all of them in some cases. You can also, at the end of a string match, use, for the return values, you can many times actually just use the array structure to identify which one you want to return back. For some of these functions, they actually return back an array of values. But because of the way Lua does returns, many of them, actually I think almost all of them, return multiple values. So this is actually, we're going to stop here for a second because I realize I don't think I talk about this in any of the slides. Lua's returns, how do I put this? Well, I'll do it like this. I'm going to make an anonymous function here and excuse that, and we'll talk more about how those work. Lua's return structure is such that if you oh God, I'm an idiot. So LuCI's return structure is such that if you give two values to return, it will assign the first value returned to the first variable, second value to second variable, and so on. Now, this becomes a little bit more confusing when, let's say, I want the first three. 1, 2, and then it puts nil in the third value. What if I only request the first? And actually, I have to kill B first. Then when I print A, B, and C, it doesn't error out. It'll essentially just pass back nil for any values that are waiting for it. So you won't receive an error if it doesn't return everything it needs. And so that's can be very confusing and very frustrating when you want it to like error out if it's not giving you everything you need. So be careful with how you send return values, because again, C is full of nil here. It received a nil, it is nil. And A, so it's still passing back a 2, but it's not erroring out even though there's nothing to receive that 2. Can be very useful if you only want the first thing and something passes back, but something else might want a bunch of other things. And so a function can do more and pass it back, and if your program wants it, you only request the things you want. And actually, Lua has a generic styling thing, which is you can pass things to underscore, and underscore is that thing that I actually don't care about and I'm not going to use. And so that helps people who are reading your code go, oh, okay, like no one's ever going to try to use the underscore value, which, I mean, it works, but like that is kind of Lua syntax shorthand for I don't care about this and I don't want to use it, I'm not going to use it, I'm not going to deal with it.
Could you do like multiple underscores until you get to one you want, or will that break?
I don't think so. I think we should just assign them in order. Let's see.
So you can't do just comma A or something. This is the notation.
Yeah, I think comma A will actually break. Let's see.
So A will be nil right now.
Yeah.
Okay.
And so they use the underscore in order to say, like, this is something I don't care about. Now, mind you, that's not, you can use underscore like a variable. You could actually have a whole program that's using underscore, multiple underscores, or whatever. Don't. Yeah, it's convention. And you'll see it in the pairs when you're iterating through, like we did earlier, a table. If I don't care about the index value, I'll usually do underscore, comma, and then the name of the object I care about. Just to let you know, I don't care about the index on this for loop. I actually only really care about what I'm getting back, like what the actual contents are.
So if you wanted to return a table, if you just put it in curly brackets, A would get the table.
Absolutely, yeah. But that's all about how you return the value, and that's based off the function. Also, an empty capture will actually return that position in the string. So for instance, let's say I don't want I don't want any return from the string, I just want the position right where this one pattern ends and this other pattern begins, so that I can then use a different, more, for instance, a function that's not as wasteful in memory to do the actual like splitting of those strings. I can use this to capture that position. Yeah. Cool. Let's do some examples. Sally Jones. You'll see that I'm using A comma B, because I'm going to get 2 results back. And this is because I have 2 chunks of things in parens. I have a %W, which is anything alphanumeric, so numbers or letters, and 1 or more times with a space, and then another set of letters 1 or more times. So I'm expecting 2 words with a space in between them. Now, you'll notice that plus, again, is a greedy thing. But because it's only plus, and matches the first thing, it's only a plus for alphanumerics, and match is the first thing. It wouldn't matter if I had another space here and more letters. It's only going to match the first word it finds, or the first set of alphanumeric characters, then the space, and only a single space, and a second set of words. If there are two spaces here, it would break. It would say, well, there's no set of words, one space past the first set of words. There's nothing to capture here. It would still capture this first word, but it wouldn't capture this word, because the space breaks the full length of that capture. And the overall capture, because remember I said %1 returns the first thing captured and %2 returns the second? As much as I hate this, %0, even though they don't index from 0, returns the whole set of captures. Returns them all. So in this case, if we match for Sally and then Jones, and then we print the variable A, which is what should capture Sally, and then dot to concatenate to %S last name is, colon, space, dot, what should be Jones, we'll get Sally's last name is Jones. And we talked about shortest capture length, so I'm not going to go over that again, but remember that's useful. Also, you can do multiple captures we just did earlier, so you saw that with Sally Jones. This is just with the letter A. For some reason, I did that twice. Let's see, what else? What am I doing here? I'm anchoring captures. Oh yeah, so I'm using the dunce cap. What's that called? Caret. I'm using the caret, thank you. And the $sign to anchor the word at the beginning and the word at the end. And then I'm using a period with as little as you can to capture inside to just get everything inside that string. So the first word in a space, and then anything that I can capture, then a space and the last word. So even in this long string, because this capture is anchored at the front and this capture is anchored with that $sign at the end, and there's no stars or pluses that allow it to like grow out beyond just a single word, we end up with this and then that anchored final word, words, as the two words that we anchor to, or because we're using the anchors.
The $sign means always the last string in the array.
This is the end of the array. $sign means the end of, end of the string.
And the caret means the beginning.
Beginning of the string. So if this right here, the first thing has to be an alphanumeric character, or it will not match it.
While outside the parentheses of the alphanumeric character, the greedy alphanumeric character indicator, the %S means break at the space, or whatever is where it's bracketed at the other end by a space.
Exactly.
And then what do the period minus mean?
Period captures anything. Minus is the capture the least amount of things that fit this pattern. Again, that fit this pattern. So it won't just like go here and then it'll be like, oh, the second thing doesn't match. It, to fit the pattern, capture the least amount of things. So stop immediately when you find that pattern. It's also nice if you have a really long string that might match a lot of things. Using that the star can actually cause it to like keep iterating over the string to find if it matches. And on some strings, huge string, I mean, I'm talking pages upon pages upon pages, or, megabytes of text. If it doesn't find anything, it'll iterate from the first letter, then from the second letter, and the third letter. So anchoring also helps you, like, say this is how big this thing must be, in order for you to not have it, like, iterating over it in a bunch of different ways and wasting a bunch of memory when it doesn't have to. Another reason to use anchors as well as stingy captures. I don't think they're called stingy, but there's like a term for it. Jordan, did you have some?
I think there's multiple capture may have just answered it, but in AB, okay, so in AB syntax, the stuff to be captured is deleted by the parentheses.
Yeah. Captures are in parens.
Okay, got it.
And then this is that balance cares I was talking about, which is, there we go. So what it's doing is we're doing the same match, and again, I'm only using string.match here for most of this stuff, except for this last example, because it's just an easy way. It captures the first thing, it exhibits these really easily. In this string, function, paren, value 1, value 2, which is a string, it's not a function. I'm using a Lua function to show you because you can actually do load string, which loads strings as a function and tries to run them. I want the pair that starts with a parenthesis and ends with a parenthesis. B is escaping these parentheses. because the next two characters after B are the raw characters it wants. You don't have to escape these, and that's why B is really tricky, is because you'd think you'd have to actually do like I want a paren character, not like an actual capture here. This isn't a capture value, this is actually the characters themselves. And this is why B can be confusing, but what it did do is it returns anything in those characters. So for instance, value 1, value 2, including these parens. It matches the parens, the raw characters of parens. In a less confusing version, string.match with name Gurbanguly Bermohamedow, who's the president of a country, like Turkmenistan, I think. Please look it up. He's the president of a country. I use, right here, I want to look at the capture of B, open caret close, or open greater than less than, to capture the name here. So that's what this first B is capturing, is this entire chunk with open and close. Then I capture, then I capture any text, the smallest amount of any text in between, using an actual capture, and then this B over here captures name again. Again, it's just looking for open and close. You can do this with, capital G, lowercase w, if you know there's no other lowercase w's in his name, and it'll capture his name as well.
Okay, so why isn't it capturing literally the word name?
It is, but I don't have that being passed back. If I had parens around this, it would pass it back.
Oh.
In this one, I don't need parens because I'm only capturing one thing. And so it returns that value. In this one, though, I'm only actually capturing it. If I had parens around this, and we could do that right now, if you like, or you grab your terminal and fire this off and copy this from the GitHub thing, you could capture the name as well. And in fact, that's what I do right down here with GSUB. And so what I've got here, and this is far more complex because what I'm actually trying to do here is I'm transforming this HTML into LaTeX, which is another like string style. I have the string I want and the number of times found. GSUB also returns the second variable, the number of times it found this string. Now usually you wouldn't capture that, and you would just not have that variable, you just have the first variable there. And again, like we were showing earlier with return values, it just wouldn't set it to anything. And it still return you the number of times it was found, you just wouldn't use it. But here I'm just capturing it so you know that GSUB, my favorite function, returns also the number of times I found this thing. And so what I have is the same gurgly-burgly, and I don't use B here. Damn it, Seamus. Well, so I have open caret, and then I capture within the open caret only the letters. I'm not capturing, by the way, alphanumeric here, just words. And then I also capture whatever is between the two HTML brackets. And then I use the numbers we had before for the number of captures to take the first capture and put it behind a control character, which, by the way, I'm escaping out a control character with a control character, not with the paren sign here, but I believe I could actually use a paren sign as well to escape it out. But yeah, that's the weirdness about, remember when I said the parens are really stupid and annoying and not regular expression based? So I just realized I can use my mouse here instead of my finger, and that'll be easier. And then I use this %1 to gather the first capture. And then I put two curly braces and then place the second capture between them. And so what I've done here is I gave the string, and in GSUB you then give the pattern and how you want to manipulate that pattern to substitute out, to return. And so you can also use %0 to say, give me the original string back, and then also give me the other variables. But what I want to do here is I just want the opening bracket and the object to return properly formatted LaTeX, name Gurgly Burgermau. I should really learn how to pronounce his name, so this is an offensive video. It's the last time I talk about him, though, so it's good. So that is pattern matching. And so we're got a ways to go. Now we're at tables, which are the coolest part of Lua. And so we've done a lot of this, so we're going to skip through a bunch of this because we've done it in other sections. These are tables. When you essentially return a table, you'll get the table and the memory address of that table in a terminal command line, which is useful if you actually want to deal with the memory itself, which you need if you're going to deal with C. For those who are planning on working with OpenWRT, when we actually get that C stack stuff built, Lua integrates really well with C. Also, you should note table.concat. This is really important for manipulating tables of strings you want to put together. Concatenating strings is very memory intensive for Lua because it makes a new string of the size of the old strings and then puts it together. And then you have to wait for garbage collection to collect those old strings. A really memory efficient way to take a lot of strings and put them together is to use the table.concat function, which essentially does that same concatenate everything in this table, starting at the first value and going to the last value, together, all the strings, into one long string, with whatever the second value you pass it is in there. So in this case, he's using commas to give you a list of the table's insides. But if you're going to be concatenating a ton of strings together, instead of going for I in all these strings, I ... other string, in a table, you want to use the concat value. Also, when you're bringing in, like when you're using Lua's I/O functionality to deal with like the let's say a file that you're pulling in, like a Commotion file or a LuCI file, you want to bring them into a table, and then use the concat thing to get the larger string. If you're going to be concatenating a lot of strings together, it's an incredible amount of memory saved to use concat over actually concatenating the strings individually, because it essentially uses the existing array structure to make it's a lot easier. Here we see the pound sign. I like how Sasha's actually in his office with all the food. Here we see the pound sign being used to give us the amount of items in an array.
And also,
This is useful because you can do things like this, which is the array T, the length of T plus 1, add grape to it. As we saw before, again, the brackets allow you to use a non-quoted string, or like a non-quoted variable, so you can do something like math in there to return a number. Make it grape is the exact same thing as just doing, table.append, or table.insert, grape, which puts it at the end of the string. Now this is cool as a replacement for table.insert, and then the item, and then this thing you want to insert into that table at the very end. Except for that, we're going to find out very soon that this shortcut of the number of table plus 1 does not work. Because this is a horrible way to identify the length of a table. This is great for strings. It sometimes works for tables. Only if you know there's no nil values in the table. So it's here. Be really wary. Know that it exists. But what you really want to use is table.insert. Because that is actually that meta table, that the controller of the table inserting it to the end of its table, not you trying to identify where it is using some cheap math. And you can also use table insert to say in the second place, insert a plum, so that plum will be the second value in that table. So you can identify, I want it in the second spot or in the third spot or at the end or even under a name. Though in that case you just go table dot whatever you want the name to be equals that value for cleaner code, and we'll cover a little bit more about how you add and talk about tables. You can also use table.remove, which removes an item from the array. And I actually believe it removes it cleaner than just setting, it just sets the value to nil. The same way you would do if you wanted to delete an item from the array, you'd set that value to nil. I think table.remove does the exact same thing. And table.sort, which sorts things. And it has a set of ways it sorts things. And you could actually pass it a second value of number or alphanumeric or length for it to do that. So now we have the cool stuff, which is tables are always associative arrays. As I said before, using a period, you can identify something and it's automatically made a string. You can use a bracket and it will allow you to put whatever you need it to be in there. So for instance, I make this a string name, it's the same as .name, but if I don't make it a string and say name, it'll look for the variable name and try to identify what that string is. Here's where I talk about why tables, the %t is not a great idea. So for instance, return %t on a array that has nothing in it, or will return 0. You insert hello, it'll return 1, and t1 works. But if I have an array ABCD, and I print, give me the number, 4, ABC, nil, D, give me the number 5, ABC, nil, D, nil, 3. What it's doing is it's running through the array, then looking, the next value is nil. Let me check the end of this array to see if there's values behind this nil. Nope, it looks like it's all nil to here. Doesn't look for the D. This is our array.
Nil.
So it actually goes then to the
Trumps D.
back and starts looking forward.
Yeah. So having multiple nils in an array breaks the way that this function was built. So the way that you go through this, like to actually evaluate a length of array, is just to iterate through the array using pairs or I-pairs. Preferably pairs, because pairs will deal with nils pretty loosely, which actually iterates through all the memory spaces that array has been assigned and checks for something to return. And then you just use that iterator function in the for loop to go, and then whatever the final number is of times that iterated, that is going to be the length of the array. It's not easy. It's a lot more code than it should be to do this. A lot of times, if I'm doing a lot of iterating through arrays to find the length of the array first, I'll write a little iterator function that does that. And so I'll say like count array as a function and then pass it the array so that it works just like this, where instead of the pound, I go count array and then put the array, pass the array to that function. So I don't have to have that code all over my code, like I don't have a lot of code reuse. But it's the really only effective way to count the length of an array. And so this can bite you. It can really bite you if you set a value to nil accidentally later, or things are getting removed and added to an array. It can be a bad thing. What's up?
Guys, what's the value of having nil values inside the array like that? Why not remove the element?
Well, so that is removing the element. Setting an array value to nil is how you delete something from the array. The .remove function, I believe, repacks the array.
Okay, so you can repack it to get rid of all the nil values.
Yeah. Yeah, you can totally do that. But for things like, and it becomes more important when you're dealing with like arrays that have indexes of your own design. To get rid of them, you just set the values to nil, because there is no ordering in them anyway, so there's no way to repack them into a more compressed space. And you would want to repack them most of the time, just because it's memory intensive to repack an array like that. And there's some great, if you look for Lua refactoring arrays, there's a lot of great tutorials on how array packing in Lua is done and why it becomes so important when you're dealing with large arrays. So far, with most OpenWRT stuff, I haven't been dealing with huge chunks of data just because we don't want to be dealing with huge chunks of data on the routers. Apparently in World of Warcraft, though, it's a big deal, I found out. So we've gotten through why that's horrible. Adding a new element to the array is as simple as just defining the element and then making that element equal to male, so t.gender equals male. Notice that's also the way that we're doing it when we actually just define an array normally. We're still setting the value of name equal to David, unlike other languages where there's a separate construct for like, name colon second thing. In Lua, we use the equal sign to say the name key is the value David. Let's see. Yeah, so if we set t.gender to nil, and then we try to get t.gender, we'll get an error because it's undefined. It's no longer in that array. Or, I mean, it is in the array, but it's undefined in that array. If we did return t dot pineapple, it would also do that. Though I default with my metatables to have every table have a pineapple value, just personal choice. And unicorn, of course. But unicorn's a whole separate set of functions. That's why the routers are resetting all the time. No, we already talked about this, so I'm not going to go too deep into it. But essentially, a table brackets 1 as a string is the same as table dot 1, or would I put table dot 1? Yeah. So any way you use it, table 1 equals table 1. It's just if you don't need to pass variables, you can just use the shortcut of the dot to do it. And also, that's how we deal with calling functions. Is usually we do the dot to represent that with globals. We'll go more in depth as everything. We can also store tables in a table to make a database. Database. I stole a lot of this from the guy. So,
Sorry, what are the return values for David and Richard? Why is David in quotation marks?
I think I typed that wrong, or he typed that wrong.
it's not.
It shouldn't be in quotation marks. On the command line, a string is always going to be passed back without the quotation marks.
Okay.
Even though it's actually being passed back with the quotation marks, it just doesn't print that way
Okay.
because printing removes the quotation marks. It is, though, a string that it's returning. So it should be in quotation marks. It's just that on the command line, which is what this is representing, this should be out. You're right. It shouldn't have quotation marks there.
Even though that's actually.
Even though it's a string,
Oh yeah, okay.
because we're returning it to the terminal doesn't output the quotes.
But if you had square brackets around David with quotation marks, it would return quotation marks.
Well, no, so it's actually returning the name. So it's returning the first value, which is inserted here, t1 dot name. We could do t1 open bracket parens name paren or not paren quote name quote close bracket because it's actually returning a nested value.
Okay.
It's t.1.name or t open bracket 1 open bracket name. But yeah, it shouldn't have the quotes there. It would only have the quotes if you, for instance, returned it to another function. It would be a string, so it would implicitly have quotes. It's not part of the string or anything, but like it would implicitly, because it is a string, be represented as something with quotes. Lua hates us. Here's why. And it loves us too. Anything can be key, anything can be value in Lua. So here I've created another, I should have done functions first, anonymous function, a function we don't name, that all it does is print on a function, and then it ends. I've also created an array that has an array, or it's an array that has 3 values that are, 1, 2, 3, and then one value that's key is last. So different types of values in here, normal indexes and last. And then I put all of those in another array where I have this subtable as the key for this st here. I have check fun is the key for this function. I have times 2 is the key for an anonymous function that I wrote right here. And this is a fully functional array. I actually did this in my terminal, and I just copied and pasted it into this thing. So I print, WTF, by the way, is the name of this array. I print WTF times 2 item, and then parens 4, because it's a function, to pass that times 2 item 4, and it gives me 8, because 4 times 2 is 8. I then go WTF dot times 2, just to show you that you can call it in both ways. You don't have to use times 2 here. 4, 8. Notice it looks exactly like when we use the string statements, because that's exactly what string is doing. It's just an array that has functions in it. It's not just an array that has functions, but and then I also did for the pairs do print. Looks a lot like the globals value. That is essentially what globals is doing, is it's nesting tables with functions in them. So that is why Lua tables love us, but they also kind of hate us, because it can get really complex and messy.
When you're indexing an array or a table, you're actually effectively running the code in that element, and just strings happen to have the default function that they run is just display the string. Or no?
I wouldn't know the internal so well. It is so it's compiled at runtime, and so I know there are some finicky bits about that I don't fully understand. but it's part of the way that it's compiled. It's actually compiling the functions the way you would compile a normal function, and then passing it, the values as such. But the array essentially just becomes a set of pointers to those functions. But yeah, I sadly don't have that amount of depth into the way that it's compiled at runtime. So this can lead to some issues with lambda functions in arrays, which I should point out because I've hit them before. So here's our array, a equals, and we have pineapple and durian. B equals this function, return durian. And then AB, okay, I'll eat it this time. And then, so I put that B function into A, and then I print it. I've just indexed B by the function. The key of B is that function, not the result of that function. The key itself is that function. So then if I want to get to, okay, I'll eat it just this time, right here, which I put into AB, which should be durian. I want durian to be B. I want the return to be B. No, it's the whole function itself. It's saying this function is your key, which makes it really hard to find that. The way around this is right here. In the brackets, you call the function. You actually give it the parens to call the function to get its return value. Otherwise, so then it actually sets. This is the exact same thing essentially. It sets returns durian to place there, and sets the light bulb instead of yuck. So just be wary of how you use anonymous functions when you're dealing with tables. Make sure that you're calling the function if you want the return value, or if you're setting it. I mean, I don't see why you'd want to set a function as a key, but go you. I'm not going to stop you if you find a use for it. And again, the same as if you run an anonymous function, like in the actual brackets to set a value, you need to not just put the parens behind it because then it'll error out. You need to actually put it in its own set of parens and then put parens behind it so that it runs it as a singular chunk. So that's how you do that. It's confusing. Well, it's not. It's all documented right here. It's very easy now. You've all learned it. Commit it to memory. Section 4 is Lua expressions and arithmetic operators. I mean, I think we've pretty much used all of these. I should put this earlier. I realize now. Addition, subtraction, multiplication, division, modulo, exponation, and negation all work in Lua. The way they worked as we've been going so far. Not equals to. You know that exclamation mark we all love? Lua hates you. It used the tilde instead of an exclamation mark. Oh, wait for it. This also negates the ability, and let me jump down to, did I not put it in here? Oh, damn it, did I take it out? It also doesn't work the way it should, like an exclamation mark. So this is some of my code. Where's my not section? Oh, darn it, did I put it? I put it in a different section. I'm sorry. So we're going to have to get there when we get there, and I'll just talk about it right now. So you can't use the tilde like you'd use an exclamation mark to put that something is not an item. You can't go if exclamation mark item then to say like if not item with the tilde. You have to use the written out not in its place. And we'll talk a little bit. Well, it's somewhere in the thing. I wrote it down, so it's there. But it should be pointed out that tilde only works in the condition of tilde equals for not equals. If you're going to use like the just not, you have to write out not. It does not equate to not. They're not synonymous in Lua. Logical operators and or not. This is probably where I have it. Oh, yeah, right here. If x does not equals 5, yes. Oh, I just didn't do the spacing right. If not x equals 5, then print n. Print yes will not work. It actually has to be, and this is, sorry, it's so small because the spacing didn't get right. If not paren x equals 5, close paren, then do whatever, is the correct way to use the not operator. You cannot use the not thing, the tilde. You have to use not paren x equals 5, close paren, or if x, not equals symbol, not equal to symbol 5. Yeah, it's not totally intuitive, but it's the truth about Lua. So here we have logical assignments. God, the ordering of this is not really the best. Oh, actually, this is going to get to fun stuff. Or not fun, but confusing, interesting bits of Lua. And, or, if, then, the whole bits, they work mostly as they should. Except for ternary operators, which do not work as intuitively as you would want. So in this case, min equals if x is less than y and x exists, or y is actually, since x is less than y, min is assigned to the value of x. But if x was not less than y, min is assigned to the value of y. And so, essentially, ternary operators look ugly as all sin.
So min is an.
So and is essentially both these things are true, or is one of these things is true. So if this isn't true, then it moves to the or statement, because both of them aren't true, and returns the y. Otherwise, it would return the x.
Even if y is true?
Well, y should be true. It's saying the first thing, there's like invisible parens around this, which says, since this and statement isn't true, give me y instead. If the and statement was true, if this was correct, it would go great, and it would give the x, and you don't need the or because there's nothing false here. It returns the first value. Just
Ternary operators are always
yeah. Well, it's gonna get funner too because you did the anonymous functions. So in the same case, if there's no error, return oh no. If error is true, if error is true, then return oh no. If it's not true, go to next step. Is essentially what's happening with the. Also, do return end this is where I was going to talk about this. Do return end is the way that you can return a value to break out of a function. Essentially, it creates a mini closure for those who like a little mini local space that allows you to break out of that function. Otherwise, the return value is expecting an end afterwards. So do return end allows you to have mini escapes from loops and the like. So just do return end is a useful, do return whatever you want to return, obviously, end is a useful way to get out. There are other ways to get out of loops. There are no continues. Do return end is nice.
Wait, you use it to get out of loops, not functions?
Functions, sorry.
Okay. Can you use break to get out of a loop?
Yes, you can. So here's where it gets weird with ternary operators. So here we have true and false or y. The idea being that if this is true, which will always be true, you should return false me. Or return y. False me is being run, it returns false, and so therefore we get y. Because this and statement is now false, therefore we get y. Down here, and I mean, this is where it got confusing, and I kind of was like, I give up. In this version of the function, where I actually make it a lambda function itself that returns false, because again I don't put parens around it, even though the lambda function is not being run, that lambda function is true. It does exist. Even though it's going to return false if I run it. It's true. So therefore it returns us our lambda function. If we correctly enclose that lambda function and run it, it will return the y. So again, and I call them lambda functions, just anonymous functions in general, as objects are true. No matter what it's going to return eventually or do, it is a thing. It's true, it counts as true. Be wary of that if you have something like an error checker that you throw into like a ternary operator, or in any operator that you call the functions. That same with tables. Properly encapsulating anonymous functions, if you're going to use them in your code, is really important for using anonymous functions, which come up in 2 more sections, and I've used like 20 anonymous functions. If statements. If is followed by, stop it. If is followed by then. So if you want an if statement, instead of for instance in JavaScript you would go if and then put something in parens and do your if statement and then open bracket for your function. Lua, because it's a very kind of written, spoken almost language in my opinion, and these parens aren't necessary by the way. Well, I mean, I think it actually is for this, but you don't have to have parens around the thing that follows the if. If whatever you're checking for, then your full function, end. Everything that is a control statement must be ended. Fors, whiles, functions, the whole bit. End is our way of closing out functions. They don't use curly braces or anything like that like other languages do. It just runs very written if, then do this thing, end. And so in this case, if 1 plus 2 equals 3, then print correct, end. And so, I mean, as we continue through this, this is pretty simplistic, except for, oh yeah, also, else doesn't have a then you need to run after it. Unless you do, I think else if runs a then. Go ahead.
Yeah, why do you need to write end after every?
Because that's how you close a...
Oh, it's because you okay.
Yeah, I mean, it's just the syntax
like
that it uses.
Terminator,
I mean, it does that to make sure that you're, it's not taking on more stuff afterwards. That's how you differentiate.
Okay, yeah.
Because it uses that syntax instead of white space, it allows you to write it all on one line like this, which becomes really useful when you're writing complex functions that are like one-liners, especially in the terminal. God, it's so much easier to use in the terminal than Python.
I was just going to comment, that might seem clear if you could actually have, multiple lines of stuff that, as part of that if statement. So it's not just if this, then do this one thing, then else do this other thing, and that seems like the end is kind of implicit. But actually, it could, that last if statement there could, be if this, then print this, and then run this function, do this other stuff, call this other thing, else print this thing, then do this,
Yeah.
create this object, and then print out this stuff, and then end. So, yeah, it's just to, terminate that.
And if could be incredibly long as well. Your whole program could start with an if. All this calculations, then all this other stuff, else, other half of the function, or other half of the program, end.
Right.
So yeah. Okay, that's if, as I said, else if is just a concatenation of else and if without a space. With a then afterwards, so anything that has an if in it requires a then, else without a conditional does not require a then. And so this is a more complex if these things, then do this, else if these things, then do this, else if these things, then do this, else for your catch-all. And then again, you have to end your initial if statement. You don't have to end your else ifs. Like every if statement must have an end that goes with it. Oh, excuse me. So that is if then else. Now we're moving. Loops. Cool. 3 kinds of loops. Those who came to the early morning session already know this, but I'll go over them again. We have the for loop, which takes the initial value, and then it takes the final value and iterates by 1 every time. So you get for, let's say, I equals 1, or I equals 0, or I equals negative 100 to 10. It iterates that value up 1 every single time, and then does whatever you want that many times. While and repeat are essentially just different control structures for the same thing. While checks a condition, and then, and by the way, while, all the loops except for, well, I guess, while and for use a do loop. Remember how we did do, return, end? And so the do then runs what is in between them, or what is after it, and the do uses the end to stop itself. So while do, if then, and then I think, yeah, it's for do as well. So while checks a condition, runs a function, checks a condition again, runs the function inside of it, or the methods inside of it, checks a condition, runs a function. Repeat, on the other hand, doesn't have a do, and it runs a set of methods, then checks something using until. So repeat will run everything first, and then check this condition until to see if that exists, if that state is somewhere. Then it'll run it again and check the until, and run it again and check the until. And so while is really great for checking something before you do any work. Repeat is useful in those rare cases where you want to do it at least once before you check. Maybe you want to destroy any state that might be left over from an earlier function. And so you run through your destruction of the old state, do all your functions, then check to see if the state is set correctly. And if it's not set correctly, you destroy the state again and you run through the functions. Hopefully this time it does everything correctly and you set it correctly. Not the best use case for it, but that is why repeat exists, is that it always runs at least once, which allows you to have some sort of kind of like cleanup as well in the beginning of your code to like make sure everything's in order and you're not going to like accidentally skip this whole loop that's required for your program to run. So repeat's really useful in that way.
If you're ever looking at loops in other languages, sometimes it's called a do while loop. Like sometimes there's like do this while condition.
Yeah.
And so this is using a for loop to iterate through an array, and this is actually the best way to count an array, as I was saying before. The amount of numbers in it is you would just you would set your variable earlier. So let's say I would be equal to 0, and then for I 5 do your thing, and then at the end you would have an I value that is actually the length of your array. So you could say, oh, well, I is equal to 5 things. In this case, we just print out the fruit in the array, which we've already seen. And again, here's that use of the underscore to signify that I don't care about the indexes in fruit. In the for loop with I pairs. You can also, wait, is that still, I don't think that still works. One second. Oh yeah, it totally works. If you call pairs with only one variable, pairs, not I pairs, pairs will return back the keys. Because again, remember, we're passing back 2 objects. We only have one object, or one variable ready to receive an object. It gets the first and dumps the second, just like functions do. The first value gets assigned to k, and then it's waiting for the second, there's nothing there, so it doesn't worry about it. And it just doesn't, it like just goes into the ether. And so what we've done here is we're actually printing out k is, and then because we have the key, fruits k. Not the best way to do it. You should actually use the 2 pairs if you're going to be using both values. Why you would want to then iterate back into the loop that you've already, like you're in the loop, you have access to that object, you're throwing it away, and then you're re-accessing the original array here. you're doing too much, but it is essentially possible, and this is pairs returns as a function in that for loop two variables, or two values. You only have one variable, just like a function, it will only take the first. Which is again why you have to use that underscore comma k to get the object if you do pairs and you just want the value and not the key itself. So just, yeah, more digging into that. Oh yeah. So let's say I want an ordered array where each item has a value, like has a key, I mean. You can create a regular array and put each item with its key and its value in a second array and use I-pairs and then iterate through each of these as its own little array. Not very memory efficient, but the guy who wrote this originally put it in there and I was like, it's kind of ingenious. If you look at that, something you care about, go ahead. So what he's done here is because these arrays have an order, because they're indexed by number in default, these arrays within them, the K is VK thing, are being used to maintain the apples, bananas, oranges, grapes. It's probably an easier way. I would actually say, like, for IV and I-pairs fruit, do, yeah, there might be an easier way. I'm not quite sure. Dan?
You couldn't really access it by the keys anymore.
Oh yeah, you couldn't access by the keys at all. It would only be useful if you, I don't even know why, I mean, like, it would only be useful if there is there's sets of objects with more than one key in each, and you want the sets to have an order to them. So like if it wasn't just apples red, it was apples, bananas, oranges, and grapes in each one of these, and they had different values, and you wanted the order to be the same, but then you would have to use sets of associated arrays anyways. I don't know. I just left it in because I thought he might know something I don't, but I haven't quite figured it out yet.
Wait, I don't understand how those got reordered. What changed?
Oh no, these would get reordered if they weren't, if they were just by their keys. Lua doesn't maintain ordering for values with any key other than the set iterative values that they give. So if I assign a value to, like if I assign keys to things, Lua doesn't care about the ordering. It does not order in the way the array was originally set. Lua doesn't order its non-indexed indexed arrays. Yeah, Lua doesn't maintain the order of arrays that have special keys.
It's totally indifferent.
Totally indifferent,
so
and it'll return them in a random
if you play around
format.
with this array later,
Not this array, but this array here. If I ran this IK in pairs fruits,
Yeah.
and you can do it like 20 times, you'll get different values for how they print out.
Really?
Mm-hmm.
Wow.
It'll return them in any order it wants. Well, it doesn't want any order, it just returns them in a kind of random order. Usually it's pretty similar. I think it's like based off memory, but like sometimes it just switches on you.
Really?
Yeah. Yeah.
Huh.
It's fun.
Why did calling pairs reorder it?
Pairs just accesses the keys in the array in a random order. It doesn't reorder it. It just doesn't access it in the same order every time.
Well, but what you basically said is, it seemed like in the next section, you are reordering it. You're outputting it again in the order in which it was imported. So how did you do that?
So that's I-pairs.
Wow.
I-pairs always runs in order because it's using the default 1, 2, 3, 4, yeah, like the default array.
But if you reshuffled them, then it wouldn't.
Yeah, if you gave them new keys, it would no longer keep the ordering because I-pairs iterates from the first item and it goes array item 1, array item 2, array item 3, array item 4, and so on. If you had a key in there, also I-pairs would go until I think the key and then break. Let me do that real quick so you guys can see it. I-pairs breaking. So if we have an array as I should. So if we have an array, oh wait, sorry, don't want that in quotes. So we have this array, Did I enter there? Okay, good. That's a legitimate array. All the values except for Bob are, well, they're given an index.
Does Bob not have an index also?
It has a
he's
key.
Not a 6 element?
No, his key is Bob. Bob is key Bob.
So if you ran iPairs, Bob would not show up.
Let's do it. So for IX, and let's start with pairs, just because do print IX.
Oh.
Now,
So it does the iterative keys first, and then it does the keys.
oh, it does the iterative keys. Bob gets assigned to Bob, but Bob doesn't interfere with the iterative key. So the next iterative key is 6 for 6.
And so in doing iPairs, it just skips anything, any name element.
Well, it doesn't know about him. It's going iteratively through, and then it goes, okay, I got 6, 7, no 7. I got nil back. I'm done. Yeah.
And it doesn't matter where Bob and the other ones show up. He'll always come at the end of the iterative list.
Mm-hmm. Well, I mean, he's not at the end. He's just not like it's not 1, 2, 3, 4, 5, Bob 6. It's 1 equals 1, 2 equals 2, 3 equals 3, Bob equals blank, 7 equals whatever.
Why did he come out after 6? Since he's before 6 in the element.
Oh.
In the array.
So what pairs is doing, and I don't know the internals of pairs deeply. I believe what it's doing is it's first checking in the same way that iPairs would, and then checking for any other things. I don't.
But probably the function doesn't guarantee order.
Yeah, like it does, and it might actually. Let's
We do
see.
it
They
again
always
anyway.
give the same order, but it might not.
Oh, it definitely doesn't guarantee it. Actually, here if we do,
Misleading because 6 is not actually the 6th element. Or I
it's
guess it
not.
is.
It's the 6th element assigned to a default
Okay,
element
so
value.
It is, as far as it's concerned, the 6th element.
Yeah, here, look. Let's do this. 2, 3, 4. Okay, so 234th element. Great.
Yeah, okay.
Where's my iPairs? There you are. 7 return nil.
Yeah, look at that.
There's past 7 we don't know.
That is dangerous.
I like pairs personally. I use pairs a lot. I don't use iPairs very much because of that reason.
Yeah.
Now, mind you, iPairs is great if you're, using an array as a set of numbers. But if you accidentally set something to the wrong number, or you set a value to nil, like you set 7 to nil because you're getting rid of it, and you don't repack that array, screwed.
Might have something to do with efficiency.
Yeah.
Or why you
Oh yeah. Oh no, it's way faster too. I mean, it's tons faster. Like the memory usage is like, and I there are soliloquies on the Lua wiki, which by the way is a really great site to go to for Lua hints. There are like huge things about refactoring and memory management and why use one over the other, and also like tips and tricks for like, oh, you can assign things and then use iPairs to get through the things that the early stuff, and then still have extra values in this array that you don't use.
So if you put, say, A4 is equal to dummy,
Yeah, sure.
would that replace 4 in that
Yeah.
in iPairs? And so 4 is just gone?
Well, I mean, 4 is not gone. 4 is now dawning.
Okay, so that's right. I guess you just changed.
Yeah, I mean, we're just like
Okay.
4 is just a key that is automatically set, and they use these iterative numbers in order to define the keys. But it's not. I mean, it's not special in any way. That Donnie isn't special, or what is it? Bob isn't special. They're both the same thing. So 7. Hey, finally we're at functions. Uh-oh. So there's this definition I have for functions that I'm going to do, apparently. Functions are functions. We've talked about them. Oh, shit. Did I not do the anonymous function either? Well, I'll explain anonymous functions then, using the terminal. Multi-argument functions. So a function, as we've seen, anyone came to the beginning session, we did an overview of functions. Anyone who didn't, I think everyone here knows functions. Can also accept 3 periods. And that allows you to take as many arguments as you are passed. What it does is then takes those and puts them in a table with the variable name of an ellipse. So to get access to that table, There used to be a special table called args that it was put into. It no longer does that, so you can just set local variable equals and then put paren signs around that ellipse to get the table back and then access those arguments as such. So you can pass an unknown amount of arguments to a function and then deal with it in this way. I don't like that because, you know, I like to know what's coming into my functions, but it's just me. So anonymous functions. Lua has anonymous functions. We've actually used them a lot in this demo so far. And they are actually quite useful in things like if A equals 1, 2, 3, 4, 5. And then we want A, let's say, because we can here, go function, and we pass this anonymous function with no name. We just type function, then put parens and the value we want to pass into it. And for instance, do, let's say, return, oh, actually, this is x. How do we do this correctly? Oh, we'd have to actually name this to do it correctly. Sorry, one sec. So we could make a function. There are better ways to do this, and I have some examples using gsub. They're going to come up later about how to properly use higher order functions, which is the next section about how we can assign these. But by creating an anonymous function like this, since function x is return x minus 1, and then end, like a normal function would be, is exactly the same as doing this. The normal function assignment for Lua. It's the exact same thing. B equals that function is function B x, turn x minus 1 end. Same thing. But this allows us powerful capabilities because we can define a function anywhere. Instead of just saying the function's name, we can write a short function in the code itself. And that becomes useful in things like higher order functions. So higher order functions are when you pass a function to another function. A higher order function is a function that takes a function. For instance, I wrote this really quick one called called stars, and what it does is it prints stars, and it prints the amount of stars of a function you pass it. So this function, stars, takes another function, and for the size of the tower we have up here, it sets x to run whatever function I was passed with the variable tower size and the iterator that I'm on, of this loop, right? So we're looping through the amount of length in this tower. And then print, and I'm doing replace star with whatever number I was passed back from the tower. So this function that I'm passing into stars, I have a couple of variations of it. One time I do this function, and I say the two values I'm passed, the full tower size and the number I'm on, return those added together, and I pass that to stars. It runs through this iterator. So the first time I get the tower size plus iterator 1, tower size plus 2, plus 3, plus 4, plus 5, because the tower is 5 high in this program I wrote. Next time I say, actually, now I want to do it, take the tower size, or sorry, take the iterator size, and take tower size, and subtract the amount of iterations I'm in. First time we get 4, 3, 2, 1, and actually the last time we get 0. So it doesn't, I don't have it put here, but we actually get a 0 one where it returns 0, and it prints star 0 times. And so these are called high order functions. And the ability to write these anonymous functions like this allows you to write really quick, clean iterations on code, well, like your haircut. Especially for awesome string-based functions like gsub, which remember when I was saying earlier that, Dan?
I was wondering if there was an analysis, I think that would be a good way to pass in callback functions too.
Oh yeah.
If you're not processing something, say, if you pass in a callback function, Just call it that.
Yeah, and it's also how Lua does closures, which I'm not going to get into, because as many times as I've tried to, I have no clue. I know they're like a separately scoped thing that does stuff. Closures are just weird, man. So I'm not going to talk about how Lua implements closures in this lecture. Please go online, LuaWiki and other places. There's some great examples of Lua implementations of closures, and also huge warnings about why you don't want to do Lua closures, but yeah. So gsub is my favorite of the string functions. And the reason is that gsub takes the string you want to give it, the pattern, the replacer, and then essentially it's the number you want to run it on. So you can actually say gsub only run on the first 4, right here. And so, for instance, if hello world, we can replace the string, by the way, by using that, using my internal function with the colon. For those who weren't here earlier, because more people showed up, all functions in Lua are in tables. Essentially the larger globals table, which we're going to jump into a little bit more later. And so you use the same function, the period, as you would use to call an item in a table, to call functions from libraries. Unless you're using a class, which we haven't gotten to yet, or a meta table, in which case you say, within me, run this function, and then you use a colon and the item. So for string functions, strings use the string variable name, colon, use my gsub function. And that allows you to do things like change string functions outside of you, or to find strings, blow away all the global variables for a sandbox, and still be able to do string manipulation on those strings. And in that case, you just do the pattern rep and the number the same way, except you just wouldn't have that string there at the front. It replaces the string if you use the internal function of a string. And then this is my long form, which is string pattern. REPL can be a function, a table, or a string. The gsub is awesome. And then change the first number of matches, and that's optional. So let's look at a couple examples. I want to substitute hello, replace it with any word on the whole string. I get back hello. I captured everything. I replaced it with the whole thing. Remember, %0 is the entire captured function we found from our patterns earlier. So I go, give me one word, return one word. Let's say I have hello world, and we say I want capture any word. And again, sorry, gsub iterates through for all matches. Unlike match, which only matches the first one, gsub actually walks through the entire function to look for matches. This is again when I was talking about when you have really greedy captures. It'll actually iterate over one word, and then 2 words, and then 3 words, and then the whole thing, and then 4 words. It'll do a whole bunch if you aren't really specific with your captures, so it can waste a lot of memory. But so in this case, I say when you find a word, replace it, substitute it for that captured word, space, that captured word. Hello, hello, world, world. It finds a word, it replaces it with 2 of those words, finds a word, replaces it with 2 of those words. Now, something more complex, like multiple captures, 1, 2, 3, 4, we say when you see a word with a space, any number of spaces actually, and then another word, I want you to take the second word, put it first, and then the first word, and replace that capture with it. And so essentially, 2, 1, 4, 3, and it flip-flops them. So gsub can be really powerful in this way by identifying the number of the capture that you found when you have multiple captures together. When you want to switch variables or kind of randomize some things in a cohesive pattern, the way that we take IP addresses and make them into MAC addresses, or MAC addresses and make them into IP addresses, you can do direct captures and translations in this way very easily with string gsub and just simple strings for the REPL part of it, the replace section. But it's also a higher order function. So I've made this huge ass function, excuse me, which is find corruption. This is my 1984 function. So it finds a list of banned books. This function says it takes a string. It has a list of banned books like Goodnight Moon, Green Eggs and Ham, and The Giver. And then a list of appropriate replacements like Twilight, 50 Shades of Grey, Da Vinci Code, and Atlas Shrugged. And then it looks through our list of banned books, checks to see if the string matches the banned books. It then alerts the authorities, and then returns to replace that banned book an HTML replacement and by the way here, what I'm doing here is I'm running the array replacements, and then in the brackets, I'm running math.random on the length of the array replacements, which since I've statically set it, and I know there's no null values and I'm never messing with replacements, I've used that pound sign. And this is, again, the only appropriate time to use this is when you've statically set an array that you know this works on and you've checked it yourself. Then concatenated with, again, the closing HTML. And so I look at authorities, return the book. If I don't find anything, I just return the string back directly. And actually, I didn't push my commits. This has to actually be returned with the books around it. Sorry, I realized because this is the old function. I must have, that's why I couldn't find any, all those things I couldn't find. I didn't push my commits from last night, damn it. When I alert the authorities, I print insert siren noise here, because I'm not gonna write a function to actually alert the authorities for a test. And then I have a sample book request, which is HTML, has a library with a series of books in it, one insidious book hidden inside of it, and then we run gsub. We pass gsub, our request, along multi-line string, which is the open brackets, which do multi-line strings. We then pass it, find us all the books, go through the thing, and find these books, and tell us what the book is in between it, capture that book, and use that function. Mind you, we're passing the function. We're not running the function beforehand, so we do not have the parens afterwards like we would do, like when I was saying, like make sure when you do anonymous functions, you always put the parens so it runs. We're literally passing it the whole function, because we want it to be run up here. Sorry, gsub will run the function. It doesn't actually, I don't have gsub's code here. I thought for a second I could just show you gsub's internals. And so we pass gsub this find corruption code, and when I run this on a cleaned request, passing it request, I get insert please siren noise here because the code alerted the authorities. It was found out. And then when I look at the cleaned request, here I have is Atlas Shrugged is the one I was returned in this instance when I ran this code. And so higher order functions allow you to have a very simple thing like, for each, when I receive a request, like in my actual program, I have a thing that when a request comes through to my library, I run this thing on it, and it doesn't have a Lambda function that's giant to do that search, and also alert the authorities and do other cool stuff when it finds a match. And so this is really useful anytime you're taking in data and you want to manipulate it in a much more complex way, like strings, to like reparse it and pass back the right value, instead of like taking in a string, then passing that string to a value, and and so on and so forth to like manipulate the string. You can kind of do it all at once by taking in the string, running a gsub on it that has a lot of complex manipulations that produces your output. Gsub can be really cool in that way. And there's a lot of functions that do this. Gsub is the only string-based higher order function, or the only higher order function in the string library.
So a practical application of this might be to sanitize form input values?
Absolutely.
That get submitted through the LuCI.
Yes, that. I was showing earlier how you can use something like string gsub to translate HTML into LaTeX. So translating into a different data format, like from JSON to blankety blank, which actually I think LuCI has, and we'll go over that when we go to LuCI. This can be really powerful for that kind of sanitization or manipulation of data as it comes through.
Could you just go down to
Oh,
the
yeah.
call again?
Sorry. So the call is right here. The return value is going to be cleaned request. We run string gsub on this string with this pattern and then this replacement. Now that replacement could be a string as we saw before, but in this case I passed this function, which gets passed the replacement. And so what gsub does is it automatically passes that function the captured string. And if you have multiple captures, by the way, it'll pass all the captures to that function. So you can have multiple captures and then have it have multiple inputs. So for instance, like if it's a book that you're receiving, like so if we captured like this more loosely, we could say if it's the library thing that we're receiving, then do this. If it's a book, do this. If it's a movie, do this. If it's a so it can be a very complex function that checks multiple parts of the input of the values being passed to it.
The function find corruption is getting just the string inside the book tag,
Yeah, I'm only passing it the text here.
but then it's returning the book tags also.
Yeah, because we're
It's getting the whole thing.
so this is %0. So if we didn't have the parens here, it would, this whole string is being replaced. This capture is being passed. It passes the captures. If I didn't have these parens here, it would pass the whole thing with books. But I'm only passing the books, which is why I had to also return book, string book. Otherwise, it would just return me a list of whatever gsub substitutes this for, which is these parens. And I can actually do find corruption. I think I do parentheses and then do the numbers in the order I wanted to pass the values to find corruption. But otherwise, it just takes the the first cap.
But it replaces the whole thing with the book tags, not just the capture, right?
Yeah, because this is a capture within a capture. This is the main capture. This is a smaller capture. The function gets passed, I think, the most specific capture or set of specific captures.
So your output there is from the better version that you didn't commit?
Which has stringable string. And actually here, let me just show you guys that so you can see. What are we on right now? We're doing, no, we're way past strings. We're on, functions. So the, this one not have it either? Wow, I never actually committed it. That's silly of me. Yes, so this one has, this one's also broken. I take it back. I never fixed it. Yeah. It should, though, have book, like right here. It should. Oh, sorry. Yeah, no, it was brief. Yeah, these should be
That's what I was wondering.
there as well. Yeah, no, that was this code is flawed. This man's an idiot. Sham! So yeah, so that's a higher order function, and that's what makes anonymous functions like this so powerful. Mostly just for making the code more readable for small things like this, but also the ability to pass tinier functions like that through. We are now on meta tables. This is where the people who have been yawning the whole time might slightly get interested. So meta tables allow you to actually change the behavior of tables, which means you can change the way that tables, operators work on tables, the way that you access tables. You can create objects with tables. You can make sandbox tables that you can't change the values of, because tables allow you to actually manipulate the underlying structure of how tables interact with each other. This is incredibly powerful and incredibly broad, so I'm not going to show you all the different ways you can do this. I'm going to show you 2 examples. But essentially, when you create a table, that table comes with a meta table. Now, the meta table is usually nothing. It usually doesn't have a pointer. But when you set meta table to T1, in this case, which is another table, that meta table is what the code looks for first when interacting with a table. So if you go, oh, I want to find, well, here, let's just show you. When it's looking for the index function of an object, which is how an object actually finds an item within itself when you look into an object, it will look in the meta table first for index, and if it's not there, it'll look in the normal table defaults for index. So in this case, local object, we make a little object. We set the index of object to object, so that it's self-referencing. And then here, much like a string, we're now setting functions within this object. And we'll call them down here as we create this object using the colon, just like we did before. So we say a new object equals, yeah, you're good. Sorry. Say hi. So what we're doing is we say when you create, when you do object.new, which is a function in object, you pass it a variable. We create a new object whose data equals the object passed. We then set the table for the new object to our object meta table, which means that they're all getting the same meta table as the original object. This is essentially a class. They're all getting the properties of the object that I've created up here. And mind you, this object only has one thing so far. It has a new thing. It can make new stuff. That's the one thing object can do, is make new objects. Also now we have a function called getData, which we run on ourselves. So an object would run this on its own data, and it just returns its data. Now self just references the fact that whatever the new object is looking at itself and not at a separate value. And then that can be used like this. We have a new guy. We use object.new. Hey, you guys. This new guy's object takes hey, new guys, makes its data equal to hey, you guys, sets its metatable to larger object, which includes object.getData at this point, right? Because it's below it. So when I say print new guy and the function getData returns self.data, which was set to hey, you guys in the beginning, and therefore any new guy I create with object.new and then some data pushes data in and now has the function getData where it can return this.
How is indexed used in this?
You have to, by setting the index to itself, you allow it to it looks for in itself first for functions, like for metatable and for functions before it looks in globals.
So anytime you're going to define functions for a table, you have to say that to specify. Otherwise, by default, it will always go to globals.
Yeah, it doesn't have an index for which to look for functions unless you set the index value of that object.
And what's the reason for the underscores at the beginning of index?
All of the default values, so metatables are essentially manipulating the internals of how these specific tables use the table structure. So you're overwriting the defaults that tables usually look for. So for instance, __ add is actually how this object interacts with the addition operator. So if you manipulate two tables __ add variables, or you make objects that have an __ add function, when you go table plus table, which usually is like error, you can't add tables, idiot. Instead it'll go table plus table, oh hey, they got an add thing, and it'll run those functions, taking in the other table. Usually I think it's the first table takes in the second table. And it goes, and it runs the function on themselves and returns something based upon those two functions. And so this allows you to make, basically your own operators to do stuff. For instance, the example I was talking about earlier is like matrix algebra, where you have tables of tables essentially. So you have these matrices of numbers. You can then define a metatable for that says, when I add these together, give me a union of these two tables like I would in normal unions of sets. When I subtract them, give me the difference of these tables. When I multiply them, give me the something else, so that you can actually define more complex interactions between tables. And this, for instance, actually this one doesn't do it. I don't think I have any that, I was going to say I thought I was going to do an example where I manipulated the actual operators. But it allows you to do things like have objects that interact with other objects, or objects that just have a lot of functions inside themselves. And because you're allowed to manipulate anything in the default values of this table, you can do things like manipulate the addition function of adding a new item. So a new index, the new index value, _new index, is what happens when you add a new item to a table. So when you go like table.item equals 4, it calls new index in that metatable. In this case, we've created a table. Well, first I'll tell you the function. This is for down here. We've created a function that's called read-only. It takes a value, creates a proxy, which is an empty table. It then creates a metatable. Now this is where metatables become useful. And the metatable contains all those functions running in this function. One of those is index, which is itself. We're going to pass it a table, by the way, just so you guys know where we're going with this. And then the new index is a function. And then these values are the values that when you create a new index, it passes the table, it passes the key, and it passes the value to new index. It takes 3 variables. And then it runs an error. Instead of what would normally happen, which is says, in this table, on this key, insert this value, which is what new index is actually a function.
So is new index a built-in part of metatables that you're overwriting?
Yeah, it's actually a table constructor. So metatables, what they're doing is they can override existing table constructors. That's why all the underlines are existing constructors. You can also put in new